In this video, we're going to evaluate the integral of secant cubed with respect to x. So we're going to do this guy right here. Well, I'm going to use integration by parts, and I'm going to split this guy up into the following. So this is going to be split into the integral of secant x times secant squared x dx. It's basically the only way that I can really split that guy up without using like a trig identity. Now what I'm going to do is I want to look for a u value that I can easily differentiate, and I want to look for a dv value that I can easily integrate and find an antiderivative of. Well, I know the antiderivative of secant squared x is tangent. Okay, if you differentiate tangent, you get secant squared. So that's going to be, this guy right here is going to be my integral piece. Okay, so I've now used this piece over here, and then my u is going to be what's left over. Okay, so if I differentiate secant, okay, I'm going to end up with, let's see here, if I differentiate secant, I believe I end up with secant x times tangent x. Okay, and if I work backward here, I believe that I end up with v. Oops, that's not a very good v. I believe I end up with v is equal to tangent x. So if I differentiate tangent, I go to secant squared, and whoops, this is supposed to have a dx at the end. Okay, so I get this. So now, this guy becomes this, the integral of secant cubed x dx is equal to u times v minus the integral of v du. So I need these guys. Well, u is secant squared x, is secant x, and v is tangent x minus the integral. Now v is again tangent x, and du is secant x tangent x dx. So what we're going to do in here is I'm going to replace, I've got a tangent squared here, so maybe I'll write that out for you here. Okay, just like that. And now tangent squared is 1 minus secant squared minus 1. And where does that come from? So I'll write it down here. Let me explain where I get that. Okay, so where does this replacement right here come from? Okay, so I have sine squared plus cosine squared is equal to 1. That's an identity. Pythagorean identity, right? Well, this is just one of the variations of it, and how I get that is I divide both sides by cosine squared. So if I divide both sides by cosine squared, this implies that I have tangent squared plus 1 is equal to secant squared. And if I move the 1 over, I get this. Now what I'm going to do is I'm going to multiply in. So this guy is still equal to secant x times tangent x minus the integral of secant to the third x dx plus the integral, because it's minus a negative, secant x dx. Now if you look at this, so remember this is what the secant to the third x dx is equal to. So what does that tell us? Well, it tells us that this guy is equal to this guy plus this guy minus this guy, or in other words, that 2 times the integral of secant cubed x dx is equal to secant x tangent x, okay, plus the integral of, sorry about that, secant dx. This guy is here, this guy is here, we added this guy over this other side, so we have 2 of them. Okay, so what? Well, let's see if we can't get this guy right here. So the trick here was to notice that I was able to generate the same piece here as I had over here. So if I move it over like this, I'm going to be able to isolate it as my variable, because that's what I'm trying to figure out what it's equal to. So it's equal to this. Well, let's try to evaluate this guy. So you probably have already done it in your calculus course, but if you haven't, here's how it works. The integral of secant x dx. Well, if I switch this to 1 over cosine and I try to use like a substitution, it won't work. Okay, you can try it, but it won't work. So I'm gonna do a little trick here. I am going to multiply by 1. I haven't changed the integral, not a problem there. And now this 1, I'm going to rewrite it. Okay, and I'm going to rewrite it as secant x plus tangent x over secant x plus tangent x. Now, the reason that I picked this, it looks arbitrary, okay, and from this direction it is. But what happens is people work backward and they realize that what they wanted to solve for, okay, so they realized what the antiderivative was, and then they worked back to get to this guy right here. So knowing to put this guy in is kind of a reverse process. So don't be confused and don't say, well, oh, geez, why did you pick this? Well, the reason we picked this is because we had some intuition as to what the final solution was going to be. So if you don't see it, that's fine, because I wouldn't see it. Okay, now what I'm going to do is we'll multiply secant in. Okay, so we're going to get secant squared plus secant x tangent x over secant x plus tangent x, just like that. Okay, now the trick here is going to be to do a substitution. So we're going to let u, well, let's pick a different thing than u. Let's let a be equal to secant x plus tangent x. Then dA, okay, is equal. Now I need to take the derivative of this. So I'm going to do that in another color. So the derivative of secant, we know, is secant times tangent. So this guy is secant x tangent x, and we know the derivative of tangent is secant squared x, and then dx. So what we have here, this is this with the little dx in there, right? I mean, that's exactly what I've got. It's this. Okay, like that. So what I've done now is I've created a situation which this is the integral of, okay, dA over a, or in other words, this is the integral of 1 over a dA. And I know that this is the natural log of the absolute value. I'll just write it with the absolute values in there. of a plus that constant of integration, right? Okay, we don't have to put the constant of integration out over here. Okay, because we'll do it at the very end. So this a was equal to this guy. So this is the natural log of the absolute value of secant x plus tangent x plus that constant of integration. But again, that's going to be put here at the very end. So this is secant x tangent x plus the natural log of the absolute value of secant x plus tangent x. And that's equal to 2 times the integral of secant cube x dx. So the integral, which was what we're looking for, secant cube x dx is equal to 1/2 secant x tangent x plus 1/2 natural log of the absolute value of secant x plus tangent x. Just like that. Okay, so a lot of work. But now we've generated a formula for the integral of secant cubed.